Assalamualaikum warahmatullahi wabarakatuh. Welcome to more examples related to cross product. Okay, so let's say we have this vector A and B, and the question is asking you to find what is the cross product of these two vectors here. So the cross product of A and B can be found by considering or constructing the following representation of I, J and K. So this one, okay, and the first vector, which is vector A, so 1, 3 and 4, so 1, 3, 4. Next, the second vector B, 2, 7, negative 5. Okay, so I'm just going to approach this by doing this, finding the determinant of order 3. So now if you have I, so you consider vector I, so we will cross out all the value that doesn't have to do with that has to do with I. We're crossing out the lines that have to do with I, so you will be left with 3, 4, 7, negative 5. Next, when you consider J, don't forget to have the negative sign, so J. So when you consider J, you will cross out this middle line here and the top part. So you will have 1, 4, 2, negative 5 to be considered further. And finally, you will consider K, vector K. So you can cross out this line and this line, and you will be left with 1, 3, 2 and 7. So next, we can cross multiply. So this will be negative 15 minus 28. Okay, this one minus vector J, negative 5 minus 8 plus vector K, so 7 minus 6, and you can simplify that to be negative 15 minus 28 is 35, negative 43, and then minus vector J, this is negative 13, this one is plus vector K, 7 minus 6 is 1. So this can be simplified as negative 43 vector I plus 13 J plus vector K. So this is the answer, and if you want, you can also represent the answer in terms of negative 43, 13 and 1. Okay, so this is another way of representing your answer. Okay, next. So demonstrate that this vector here is orthogonal to both A and B, where A and B are defined as three-dimensional vectors. So for this one, so you need to show that first A cross B, this vector, when it is orthogonal to A, that means the dot product to this vector must be equal to 0. Well, this is what you have already seen when you talk about dot product. So in the previous video, we have talked about dot product, and we can show that if vector A and vector B are orthogonal, the result is going to be 0. So this one is a vector, this is also a vector, so you can show that this is orthogonal to this by having a result here becomes 0. So this is what you need to show for the first part, and you also need to show that the cross product of A and B is also orthogonal to B, to vector B. So it's also orthogonal to vector B, and the answer should also be equals to 0. So this is the second part. A cross B is orthogonal to B. So this is the first part. So this is the second part. So you need to show that both are equal to 0. So I'm just going to show you the first part, and I think you will be fine and you can do it on your own to demonstrate that the second part here will also equal to 0. Okay, so first of all, what is factor A cross with factor B, the cross product of A and B? Well, it is given the formula here, so now it's a good time to use the formula because it's easier. I mean, instead of go back from the very beginning, which is doing this, I think it's just quick to go ahead and use this formula here. So we're going to use that formula. So this is A2B3 minus A3B2. So that is the first component. Next we have A3B1 minus A1B3. So that's the second component. And the third component is A1B2 minus A2B1. Okay, next we need to know what is the component of vector A. So this is a three-dimensional vector, which is just A1, A2, A3. So what happened when you multiply or when you find the dot product of this with this? Okay, so the result will be according to what you have seen before, we are going to multiply the component accordingly. So for example, the first component with the first component, then plus multiply the second component with the second component, plus this one you multiply the third component with the third component. So what we have next is we are going to multiply A2B3 minus A3B2 with A1. So this is multiplied with A1 plus, next this one, A3B1 minus A1B3 with A2 plus this one, A1B2 minus A2B1 with A3. Next, we're just going to expand, take out all the bracket. So you will have, for the first one, you will have A1, A2, B3 minus A1, A3, B2 plus A2, A3, B1 minus A1, A2, B3. Next, you have A1, A3, B2 minus A2, A3, B1. Now, based on that, I hope you can see that for this one, A1, A2, B3, we also have the same component over here, A1, A2, B3, but this is a negative, this is a positive, so you can cancel that out. Next, for this one, A1, A3, B2, a negative component, but this one here we have A1, A3, B2, which is a positive component, that can also be cancelled out. And of course, you can see that this one is positive A2, A3, B1, and this is the negative A2, A3, B1, which can also be cancelled. And you have managed to show that the answer is going to be 0, and this is just a number. So because of that, we can say that this vector here is orthogonal to vector A. So using the same idea which I have explained to you, you can go on and try to demonstrate that this vector is also orthogonal to vector B. Okay, let's move on to the last example in this video. So a geometric interpretation of the cross product is given as follows. So if theta is an angle between the vectors A and B, where theta is between 0 and pi, then this is the magnitude of the cross product. So this is magnitude, this is the magnitude of A, this is the magnitude of vector B. So the magnitude of the cross product here is equal to having the magnitude of A multiplied with the magnitude of B multiplied with sine theta, where theta is the angle between vectors A and B. Okay, so now let us consider this simple example of applying this formula that you see here. Okay, so find the angle between the vectors U and V by using the cross product. Of course, you can find the angle between these vectors if you want to use the dot product. There is a formula related to the dot product, which is A dot B is equal to the magnitude of A times the magnitude of B cos theta. So this formula also can be used to find the angle between the vectors. But in this example, it is specifically asked you to find the angle between these two vectors using the cross product. So we are going to apply this formula instead of this formula which you have seen in the dot product. Okay, so now first of all, we are going to start off with finding what is the magnitude of U cross V. So what is this? Okay, so we're going to start with finding the cross product of U and V. So U and V, the cross product of that is equal to, okay, I'm going to resort to this approach because it is easier for me. I don't need to remember the formula. So for the first one is vector U, so this is for vector U, 1, -2 and 3. Vector V is -4, 5 and 6. And this is equal to vector I. So we will have -2, 3, 5 and 6 minus vector J. So you will have 1, 3, -4 and 6 plus vector K, and you will have 1, -2, -4 and 5. And that can be simplified as vector I. So cross multiply this, so you will get -12 minus 15 minus vector J. 6 minus a -12 is plus 12, plus this one is vector K. 5 minus 8. Okay, and that becomes vector I. This is -27 minus vector J. This is 18 plus vector K. This is -3. And that can be further written as -27I minus 18J minus 3K. Okay. Right, next, based on that, you can find what is the magnitude of this vector. So the magnitude here is just going to be taking the square root of -27 squared plus -18 squared. Let me just write it properly. So -18 squared plus -3 squared, and that will be equal to, if you punch in your calculator, this is equal to the square root of 1062. Okay, so that's the first part. Okay, next we can go on and find what's the magnitude of U. So the magnitude of vector U will be, magnitude of vector U is 1 squared plus -2 squared plus 3 squared, and that will be 1 plus 4 plus 9, which is just equal to square root of 14. And you can also find the magnitude of vector v. So magnitude of vector v is -4 squared plus 5 squared plus 6 squared, and this is equal to 16 plus 25 plus 36. So 16 plus 25, 36, 41, 47 plus 30 is 77. Okay, so this is square root of 77. So once you have obtained that answers, okay, I'm just going to erase some part of the slide here. So now you have managed to obtain all the magnitudes required. So we are just going to apply the formula given in the purple box above, and therefore next what we're going to do is we're going to apply the formula. So therefore sine theta is equal to the absolute value, the magnitude of vector u and v over magnitude of u times with the magnitude of v, and this is equal to 1062, the square root of 1062 over square root of 14, and this is square root of 77. Okay, so you can punch in your calculator. You will see that sin theta is about 0.992551, and therefore by taking the inverse sine, theta is about 83.0023 degrees, which is just equal to 83 degrees. Okay. Alright, I think that's all for now. Thank you very much for watching, and I'll see you in the next video.